Hey, I'm going to go over the operation of the controls of this furnace, and it's going to be fast. You might have to pause it and watch it 5 times to listen to me. Right now this furnace is holding. Flashing the word hold. I can stop it by holding the button for 2 seconds. If I just press a button fast, it's a different reaction. So the buttons have short press or press it long for like 2 seconds. All 4 buttons are similar. When you first cut on a furnace, plug it in the wall, you turn this lock knob on, and we leave it on forever. It only operates the controller, not the heating elements. This is a relay on and off. Does it work?
No, we have to push with something right there.
Oh, really?
Yeah.
Okay. Well, this is an old furnace that we beat up these furnaces really hard. Like what? Right in there?
Yeah, you need 2.
What?
You
2
need
at the
2.
same time?
Yeah.
Oh, great.
Yeah,
Okay.
because it's broken.
Oh, then my button's broken. What?
Push this one first.
I'm not. There it is.
Okay.
Okay. Anyway, we leave that on forever also. This is like this because some people hardwire it in the wall without a removable plug, and if you wanted to change heating elements, you would use this. It's just an optional way of wiring it into your building. But so that's on. We leave those on forever. To run a program, I press run for 2 seconds and release. We can see what step it's at by pressing this upper left button with a short tap, and I can force it to any step I want. For this program, this centering program, step 7 is the end. And if you just wait like 8 seconds, it'll go back to the previous screen. There's no enter button, so I changed it to step 7, and all right, maybe 10 seconds. So now it's back to holding at the end of a program. And it holds at the end of a program to keep the glass from popping off of the heating elements. Can you get in there really close? And you can see my heating elements have turned kind of bluish color, but it takes like 200 bakes for that to happen. In the beginning, the heating elements go through crazy colors, dark brown, orange, different colors, and then they turn blue. At the end of a program, at the end of a cycle, it should be holding, and we have it holding above boiling. It's about well, you can see the chamber temperature is 130, even though we have it programmed at 114. But you have to leave the furnace like this always, or the glass on the elements is going to pop off and delaminate. It's a mismatch of coefficient of thermal expansion. The metal doesn't expand and the glass does expand. And if it gets really cold, well, if it just gets room temperature for like 1 day, the glass comes off. And you have to bake it empty, and the glass will melt and cover the heating element again, and then you could use it with zirconia if you care about the opacity, the color, the translucency. I'm going to stop this cycle, and now we're going to look at the program values of this cycle. Cycle. Step 1 in Celsius starts off at about room temperature. T for time, step 1, 30 minutes to the next temperature. The next temperature is 300. It could have been 30 if we just wanted it to hold and do nothing for 30 minutes and just like drying. Now we got a time for step 2, 30 minutes to the next. I'm just doing a short press of this. The next temperature, 1150, then a time of 40 minutes to the next step, 1300, 40 minutes to the high temperature. We got the high temperature 2 hours. I really think 90 minutes is enough, and nothing looks any different to me more than even an hour. But then it finishes that 120 minutes at the same temperature, 1480. Then we have a cooling period. Then we have the final temperature that we are holding. It's like an idle temperature. Then the last time value, we program in a 0. And if there's a time of 0, it tells the computer to hold and don't look at the next step. So there could be a step 8, but it's not going to go to step 8. This controller has a total of 50 steps. And if I wanted to adjust the temperature, I just press up and down. If I press up and hold it, it starts the single, then it goes to tens, then it goes to hundreds and goes really fast. And if I wait, this decimal moves back, and now I'm adjusting a single digit. So the decimal point jumps around. If I hold it up, then the tens, then the 100s, and then back down. And I wait, there's no enter. Or we could go to the next step, there's a time value, etc. Then don't touch anything, and it goes back to the default screen. You really shouldn't press any more buttons. It has a whole lot more to it. Like, it's like a 50-page manual, but I don't want anybody to read it or mess with anything, because everybody just breaks their furnace. So I'm gonna wait. They don't break it permanently, they just screw up internal settings of all sorts of stuff. So we can do run, 2 seconds, and stop. To see what step it's on, it says it's on step 1. I'm going to change it to step 2. Just to show you an example of, you can force it to go to step 2 or step 3 to go faster. There's a lot of different reasons why we might do that. We do crazy stuff to center fast at the end of the day. We use multiple furnaces. Have one already really hot, one like medium, and transfer work over, shut the door really quick. So now I'm going to look, it says it's at step 2. Now I'm going to go to step 7 where it's idling. I pressed both buttons at the same time. Actually, the right one slightly before, I call it snake bite. And then you could do that and it goes back to the default screen. If at any time you see some crazy stuff, like you've held like something like this, don't press any buttons. Or P equals 8 or T equals 4, don't touch anything. Just stop and wait for it to go back. Nobody needs to know that stuff. Alright, so it's going to go back in like 3 more seconds. When the furnace is cooling down, we don't open it up until it gets maybe in the 400 Celsius is when you can like open it up and remove work, shut it, and we use over here. Let me show them how we. Yeah, we use these pizza grippers like this. Remove work, let it dry. We only put a little bit of beads in, just enough. Well, maybe it needs a little more in this one. That's all you put in?
Mm-hmm.
Really?
Mm-hmm.
Oh shit. That's just not much beads. It's only so bridges can shrink, passively and not drag against the floor or. Yep. And when we put in work, we put them in like this. We're going back over to a furnace. Boom. Sometimes we put trays, we used to put some trays upside down to get our work higher up, but I don't know, we quit doing that. Just stick it in there just like that. Looks the same to me. Yep. And you can put in some trays sideways, like on top, or you don't do that? No.
Well, I put 3.
On top, one.
I put 2 on the bottom and
2
one
on the bottom and
yeah.
one more on top.
Mm-hmm.
Yeah, we stack them sometimes, but you try not to completely cover up the zirconia underneath, well, we don't want to do that and make a closed chamber because we want the heat, so yeah, we would do something like that. Yeah. Then if you ever get into a crazy situation, you're welcome to call me up. My phone number is 804-513-7153. These are Axis motors for mills. German mill. A German mill, another German mill. 2 Haas mills. German mill. This has a laser beam tool measurement system I added from Renshaw. They custom made one. Really tight towers for more accuracy for these little dental tools. We usually cut titanium in this machine. Oh, show something else. I built this. We modified the heck out of this. It took forever. This was made in my city. We designed this to hold this rotary assembly sideways, and an adapter plate, and a German self-centering vise, and these fixtures we made. Sometimes we switch to square fixtures to hold square rectangular parts. These are tool holders. Yep. Clockwise. Oops, I should have done coolant first, and then start. All right. Yep, more German mill, German mill. This guy's cutting titanium. Let's check it out. Stop. Stop the coolant. Cutting titanium implant parts. This same self-centering vise, we just turn one nut and the two things squeeze together, the grippers, fixtures. So it doesn't really matter how thick our part raw stock is, we just clamp. And we could use a wide range of squares, rectangles, and different thicknesses, clamp onto it. Coolant first. Clockwise spindle, start my axis motors, and back to cutting. Yep, more German mill, another German mill. These all have chiller units to keep the spindle at a constant temperature. It's like air conditioning. Yeah. Another one, and another one. Little Chinese mill we're playing around with. Spare spindles.